everyone, and thank you for joining us today for our HashiCorp Hangout hosted by John Boero of our Solutions Engineering team. I am coming to you live from Amsterdam today as we gear up for Hashi Days Amsterdam next week, and John is based in London. John is going to show you how you can use Terraform Enterprise to instantly spin up elastic Kubernetes clusters. After the demo, we will take live questions from the audience. I also want to note that this Hangout is recorded. So the recording will be made available after post-processing, usually within about a day or two. I'll email it out to all of you. And these Hangouts are just 30 minutes. So with that, let's go ahead and get started. Take it away, John.
Great, thank you. Hello, everybody. Can you all see my screen okay? Actually, Amanda, can you see my screen okay?
I can. I see your GitHub and then I see your portal.
Perfect, okay. Thank you, everybody. Yeah, again, my name is John Boero. Coming from Chicago, but I'm based in London for HashiCorp. And I'm just kind of following up on if you are following the Amazon announcement about the EKS and Terraform provided that another SE of ours, a SE manager, John Benson, did about a week and a half ago. I'm here to kind of expand on that and say, okay, well, you know, a lot of our HashiCorp Terraform demos do a quick provision. They start you up and they get you going and curtain call. You know, how great. What about the rest of it, right? What about the life cycle and how to manage that going forward? And in order to do that and show the benefits of the automation present in enterprise, I showed a couple of tweaks to this code and I kind of made it enterprise savvy, so to speak. So a bit of background, if you're new to Terraform, Terraform is HashiCorp's cloud provisioning tool, kind of a platform, whether you're using open source on CLI or using enterprise via our SaaS or on-premise private solutions. We take code repositories, mostly from Git or enterprise Git solutions. We digest what's in that and use it to describe infrastructure, how it should be deployed, and then also how it should be managed and torn down, right? Destroyed at the end of it. So the previous example, we demonstrated our Terraform Elastic Kubernetes clusters, which are the new feature of Amazon. Amazon is really collaborative with us in the sense that their developers are always up on our feature set, right? So luckily we were collaborating good enough to have this, or well enough, I should say, to have this available on the go day for EKS, right, day 0. So you can follow along at home. You can replicate this, fork the repo, it's public, do anything you want to it. Keep in mind that I've got quite a hairy bit of branches here. I shouldn't say this is all of the solution engineers at HashiCorp contributing to this. I'm going to be working on mine in a HashiHang branch, and I'm going to make that public, and we'll share the link later. But what this started out as was two sort of workspaces, so to speak, right? So two directories. One that uses the EKS provider to provision a couple of things, VPCs and policies and security groups, as well as the worker nodes and EKS cluster. And also to make sure that it's up and running in EKS, right? One of the tricky bits about this, and I myself found immediately, I saw this is great, let me make it work in the EU regions. Well, guess what? EKS is only available in US West 2 and US East 1 right now, which is Ohio. So Oregon and Ohio, the O states get EKS, the rest have to hang in there for a little bit longer. That isn't to say you can't use AKS, right, Amazon Kubernetes Service. This is EKS, extending on that to say, rather than have a static Kubernetes cluster, we want to have an elastic auto-scaling cluster, right? So this kind of pairs it with an auto-scale group and helps you manage it a little bit smoother. So if you're following with the open source example, great. If not, we'll start from scratch. You can clone this repository, enter this directory, maybe set a couple of variables if you want, right? Cluster name, etc. You'll also have to set your AWS credentials, usually as environment variables, right? And have the AWS CLI present. When you Terraform init, everything is configured locally, and a plan is, then you Terraform plan, you create basically a compilation, a list of JSON and what you're going to assemble in the cloud. and then you do an apply. So interesting thing about enterprise, when I'm both using GitHub SaaS, right, public GitHub, and Terraform SaaS, I don't have any actual machines required here, anything involved. I can do this from my sofa on a Chromebook with a, I don't know, a cup of coffee in my hand. I don't have to do any setup because all of the, all of the challenges, I should say, present on an on-premise solution, TLS, DNS, and trust between those is already configured. And anybody can follow along with this, either open source or enterprise via trial. If you want to trial, just go ahead and sign up on here. What I've done, instead of just a local Terraform init and Terraform plan, I create a new workspace, right? And I create a whatever name I want for it. I have my GitHub already set up. I can browse my repos, Terraform guides, and then one of the things that people often confuse with Terraform in an enterprise sense and Git is that a workspace is not necessarily a repository, right? A workspace is a repository branch in a directory. So I can have many, many workspaces off of one repo. And when I set these up, I've already entered this, so it obviously auto-completes for me. But I will create a local Terraform workspace pointing to this directory in my branch. And this will go and set webhooks up in that repo for me, right? So the beauty of that is that anything I commit to Git will directly result in a new plan. And in fact, I go a step further. When I created this workspace, I say, to hell with it, we're dev, we're a demo, we'll do it live, So I say auto apply, right? Not just manual apply. I don't want to skip everything. I want, okay, my pull request has been admitted, everybody's agreed it's okay. Generate the plan and apply it directly. And guess what? If there's an error, I will be informed, both in Git and in Terraform. So let me try. What do I have out there right now? I have, this is my Kubernetes cluster. If you're not familiar with using kube control and EKS, it's a little bit tricky. And I need to hide this. Sorry, hang on a second. You have to authenticate with Kubernetes by the API Heptio auth tool. Okay, so what that ends up looking like, and I think if I nano this is crazy. You're gonna think I'm crazy, but got my kube config, which is actually an output of my Terraform run, generates a kube config for me. You know what happened? I've got a British keyboard layout all of a sudden. Okay, there we go. Here's my kube conf, and I've truncated the CA data, obviously, because I don't want people to see that. This gets dumped to my screen during the Terraform apply. I can actually browse this in my run history and ignore the applied errors. I've encountered all kinds of errors and had fun with this along the way. It's generated as my outputs, right? How handy is that? This happens in open source as well. One of the tricky bits about differentiation between open source and TFE, enterprise, is that I get an output here of my kube config, right? That's great. If I use a provisioner, I can automatically use that to do provisioning in this repo. I'll show you where that happens. Local. Check this out. This was present in the original branch. I had to comment this out because if I'm running a local kube control, that binary has to be present, and in a SaaS environment, that's not going to be there. So I end up provisioning quite a bit of this locally or skipping altogether, right? I can do this manually or whatever I choose to do. But when I save that kube config, I know where I go with a valid AWS session. I can use kube control just like it's anywhere else, right? And I may go in and see that I've got 2 nodes. I may see that I've got 5 nodes depending on my load because it might auto scale. In fact, if a couple of you decide you start hammering my services, I might get more. We'll see. Nobody, please spare me the hijinks of trying to compromise the Kube API server. Yes, there are credentials up here. I'm going to wipe out everything after the demo, but please try to not to mess too much with the config if you're getting into it. The good thing is I would like to see, now that we have, I don't know how many people on, that we can try to maybe generate some traffic and create a bit of auto scaling. It might take a while, but we'll do the original example was, now that I've deployed my cluster, I'm going to deploy pods, right? This is much simpler workspace. There's not much involved. I've got Kubernetes namespaces uncreated. Here's the tricky bit that I've had to add as well, a remote state lookup, right? So I've got 2 workspaces, each having a different state on the one repo. I'm going to need to get my my cluster name, right, and be able to connect to my cluster from this other workspace. So I'll use the Atlas backend and connect to my other workspace, which is great. That works seamlessly. In my experience, it's been a great way to hand over between workspaces and not have to sort out issues, right? I can also include these as variables, and whereas open source, I would have to define those in a variables file or a Terraform.tfrs, I can now define those in the console itself. And not only that, but using the Terraform's built-in Vault server, I can include things like my AWS credentials and make them write-only, right? So I put these in there. Nobody can see them again. In fact, I can't even see them, which is great because the only thing that's managing that is Terraform and Vault in the back end. Okay, so what I'll do then, I'll double check here. My pods are not created. I must have done a destroy here. No, not an EKS cluster, but the pods workspace. I can check the runs. And yes, queued manually for destroy infrastructure, right? If I decide I want to shut down for the weekend, or it's Friday night, our dev environment is clearly useless, nobody's going to be developing, I can save some money, I can shut everything down, right? I have to set this variable, environment variable, in here, but I can then go in and queue destroy plan. So that will just undo everything that's created, shut it down for the weekend. It can be queued by API call or a cron job if I want to. I can do that locally as well on the CLI with open source, Terraform destroy. And then I can delete it if I never want to see this again. I'm going to keep this around so that I can continue to look at my old runs and my old states and use it for reference. But as I'm logged into Terraform Enterprise as an admin in this org, I can do everything I want, right? Well, let me try one thing. Let me try, first of all, looking at the code. Let's see what I've got it set to right now. So we're going to spin up an Nginx pod, and we've got an image name as a variable. Again, there's 2 ways to do this. If I focused on a workflow in GitHub, I can do variables in the code itself. If I decide I want to do a Terraform workflow, I can do variables here, right? The difference is these don't take a pull request, these just change on the fly, right? And do a queue plan. In fact, if I do change one, yeah, I have 2 options, save and plan, right? I don't have to download the latest code, I just have to redo a plan and a run with the new variables, okay? So if I do this currently, it pulls in my latest code and it takes the Nginx pod image, Nginx latest, right? This is a blank pod, just a default Nginx page. And that's
hey, John.
Yeah, sorry.
Sorry to interrupt you, but can you actually zoom in on the screen a bit? People can't really see the.
Sure.
Yeah, yeah, that should be a lot more.
All right, it is a big screen. Apologize for that.
And then, yeah, I think maybe one more time.
One more time. Okay, is that all right? Everybody read that? So this is what's going to deploy. I'm going to create a pod with a name. I'm going to create an entire namespace, right? And if I choose to, I can modify this, add more pods, add more services, add other namespaces, or I can create a whole new directory and workspace, I should say. So let me go in and do a manual apply. Manual plan. And in the background, I'm going to, I'm going to keep an eye on my Kubernetes. Okay. So what's happening? It's taking the code, doing a syntax check. Oops, I'm sorry, the screen is zoomed in too much. I didn't even get to see it. It's already applying. Right. If I had set it on manual, I would have generated the plan. The plan would say syntax is valid. Everything looks like it should be okay to run. And then it would be waiting for an apply. Right. And there's my output. You can see in the background, I've got new namespace. I've got namespace. I've got namespace. I've got a load balancer that I created. I've got a service, and I've got something I can actually reach if I do this, right? And this is where, if anybody starts visiting this, in fact, rather than copy and paste it, I could probably paste it into a chat somewhere, can't I? Amanda, are you able to paste into a chat? Or can everybody see that? Probably I've got it copied by now as I try to figure out where the chat is. There we go. I should probably test it first. And DNS isn't propagating. Let me see. What I can do. Apologies. So my normal machine is a Linux box, and I'm remoting into that with Windows because the webinar client. So there we go. My machine can resolve that great. This is now coming from my load balancer from my Kubernetes services, and it's widely available, right? Now I can paste this. I put it on port 80. It's a little reckless, but we'll do it anyway, right? It's just a demo. So interesting thing is now I did this workflow from Terraform itself. What if I want to change this? If I decide that the team needs a new image or a new application, how about this? I can do my normal workflow here. I can set this to a different image or a different version tag, and then do my pull requests. And if I'm open source, I can then run it manually or via a tool or cron. Or in this case, I'm just going to rely on my webhook. Right. So if I hope everybody can see this now. It's too big for me. I need to zoom out. I edit this. I've got a slide deck I'm going to put out there. I'm going to put that latest. And this is just Nginx plus a basic Java kind of 3JS, Reveal.js, if anybody's used that. Let me take this off, making noise. I'm going to, yes, I'm reckless. I can commit directly, but I'm going to do a PR, right? Propose that. And I'm going to pretend that people have to approve that. I'm going to approve it. Sure, why not? It's kind of like being a dictator, right? I will create a pull request. And the good news about GitHub, we have a couple of Git integrations, but GitHub has a real nice native branch testing, right? So it's doing it's triggering a plan on both of my branches. I'm sorry, both of my workspaces. And I can see that they're valid before I do anything. Some people use Bitbucket, some people use GitLab. They each have a little bit different functionality, but this is reverse kind of bidirectional communication between Terraform and GitHub. Right? I can see that everything's fine. Syntactically, it's valid. Guess what? I might have a bad Docker image in there. I might have something that Docker can't pull, but I won't find that out until I do my my apply. Luckily, as I'm being sloppy for this, it will just go straight through. In fact, delete my branch. This is already running. In fact, it's too big, too big. There we go. See, these both triggered. They're planning. One is already on applying because this is the one that has changes. Okay. And I should be watching over here. Maybe it's too late. Where is it? Where is it? Nginx HashiHang. Services, daemon set deployment. Oh, it's not there yet. Okay, but if I refresh, it is there. Okay, so I just changed this entire application with a pull request, right? And anybody should be able to browse to that, and it's changed. The interesting thing about that is, guess what? I can revert all of this. I can go back and say, undo this pull request. I want to restore my previous state. And that's also by Git workflow, right? So if I have two people that are required to approve my changes, I've got full responsibility and full audit trail of what happened. Not only that, but I have a link in here inside Terraform that says, okay, what commit was this? What commit was it, and what did it change in the plan, right? That's really useful. And again, that can work with open source too. It just takes a little bit more work to sort out your your branches and your commits. And in fact, here, let me check the, here's the two outputs that came, and here's my plan. What would change? One change, right? This is logged forever. It's got a timestamp on it. It's got my name on it, full accountability, and it's logged, which is fantastic. Again, if I want to have other team members in here, maybe people that just have read to look at the histories and runs and Terraform, I can do that as well. I got full exportable log history. I can use API to pull this out into a kind of a data warehouse or whatever I need to do. And I'm trying to see, there's no real indication in Kubernetes of the cluster load, but I'm not sure how many people are hitting this. It's not a very heavy application. There's no database. In fact, it's running remote, so it's pretty sluggish. But it should create a reasonable amount of web traffic. And if I go inside my Amazon console, I can see this cluster. In fact, I can see the credentials that nobody's going to get into, right? I can also look at my EC2 instance that it creates. Interesting thing about Elastic Kubernetes services is that if you've used a management service like this before, kind of an auto scaling or cluster Kubernetes service, usually there's an HA auto recover, so that if someone goes and deletes one of these manually, which is kind of a noob move, guess what? That comes back. You delete it, you think, okay, I've terminated my instances, I'm going to go home for the weekend and save some money. You come back on Monday and everything's been restored and it's been billing you. So be careful that you want to destroy all of this at once with the Terraform destroy, right? In fact, that's what I'll do right now because I kind of cheated. I started out maybe a little bit ahead of the curve and I already had it running. I'm going to go and do the opposite. I'm going to wreak havoc and decide it's Friday. In fact, happy Friday, everyone. Happy solstice. I'm going to tear this down.
Hey, John.
Yes.
Okay, so I think we just have a few minutes left, so can we do a few quick questions?
Sure, questions.
Okay, so
absolutely, we'll do this.
We'll just power through these, everyone. So first question, so this is great, John. This is on Amazon. What about Azure or GCP?
Sure, guess what? This repo is shared between all of us in the SE world and the solution engineer world. All of these examples are publicly available, and there are other examples. There's GKE, there's OpenShift on AWS, and Azure as well. So everybody can play with these on their own. Everybody can extend them, copy them and fork them and use them privately. That's fine. Everything here is licensed public domain. So.
Great. Okay. And then, so someone's asking, can we use our own security groups, VPCs, and subnets instead of creating new ones?
Oh, yeah, absolutely. In fact, that simplifies a lot, right? I don't need to recreate it if it's there. So as this was a from scratch demo that we like to stand up and tear down, we like to use our own environments. But what I'm going to show you then if I get on the right branch. This always throws me off. Is I'm going to go in and view the actual cluster provisioning, right? Rather than, first of all, the providers, my region, etc. And interestingly, again, don't change the region because this isn't supported in any other region yet besides Ohio. Look at, you can take all of this out, right? If I don't need to recreate IAM roles or security groups, that's fine. I can just reuse them as long as I specify that in the actual cluster provisioning, right? I need to make sure that I either include them as variables, whether they're set in code or in the Terraform UI, or I need to hard code them, which probably isn't the best way to do it, but you can do that as well. See, all these variables can just be replaced with your static IAM roles. Okay, does that answer that question?
Yes, so thanks, John. Okay, next question. Are the GitHub webhooks a feature of Terraform Enterprise only?
Unfortunately, they are right now. Some people, in open source world, can kind of custom make open source webhooks into a system like CI/CD solution. A lot of that is manual, as far as I know, and that's one of the reasons that we created Terraform Enterprise, was that it gets to be kind of chaotic when you're trying to support your own webhooks like that.
Okay.
The bidirectional information with Terraform Enterprise is just really, really the easiest way to go. I hate to say it. I'm not here. I'm kind of here to sell it, but you know what? Open source solutions do exist. People use Jenkins for this. People can kind of hardwire a solution, or hotwire a solution, I should say. It's up to you.
Yeah, and I guess to reiterate, like, John, do you want to kind of just say quickly, or I can, about how we think about open source versus enterprise with all of our tools? They're kind of different approaches of it.
Sure. So if you're familiar with the entire Hashi stack, what I would say, people might give me hell for this, but one of the predecessors to Terraform, Vagrant, right? A lot of people have used Vagrant, just a quick scripting in Ruby with extensibility that you can provision VMs locally, maybe even on a cloud provider with a plugin. Terraform is much more robust and is written in bits and pieces, mostly in Go. And even the enterprise itself is running in distributed containers behind the scenes with the open source bits, right? So I can go in here into my workspace and I can actually select what Terraform version. And this actual binary running these is pretty much verbatim open source, right? It's just the management layers around it that make enterprise. So that's the little bit of extension on from the, the open source example we did earlier.
Yeah. Yeah. Okay. Yeah. And then a lot of our enterprise tools, or all of them, they're really built more for larger organizations, larger teams. So for a lot of companies, depending on how many operators and whatnot you have, open source is a great solution. It's just that our enterprise is focused more on supporting teams and that sort of structure.
Sure. And it's one thing in a demo to see all these runs and there's my face next to them. That's kind of lame, right? Your org could be made up of 20 people collaborating on this, and someone commits something from Git, their name shows up. This is just very much tailored towards teams. So yeah, as a lone developer or experimenter, I would probably be fine with open source. But when I work together with teams, that's where this comes into play. Okay.
Awesome. Right. Okay. Yeah, and I think that's it for today. We're out of time, but so thank you, John. That was great, and great questions from the audience. I hope everyone enjoyed today's Hangout and has a better understanding of how quickly you can spin up elastic Kubernetes clusters with Terraform. Thank you for joining, and a big thank you to John for his time today. Also, I mentioned at the beginning, I'm in Amsterdam right now for Hashi Days. So Hashi Days takes place Tuesday and Wednesday of next week, with lots of amazing speakers, and we definitely have some exciting product announcements coming as a little teaser. So tickets are sold out, but we have released tickets for live streaming. So if you're interested in that, you can check it out at hashidays.com/live. And then, as I mentioned at the beginning, this is recorded, and we will make the recording available on our website after processing. Everyone who registered with the recording link from today, along with the link to Hashi Days Live. So you can keep your eyes out on, usually posted on there. So with that, we are all done. Thank you, everyone. Goodbye.
Have a good weekend.